All right, this is take two. Take one, I had to just test it out a little bit. Welcome to Starbucks and San Antonio, everybody. Clearly, I'm working on a few things here and taking up like a whole table. Yeah, so just let everybody know sort of where things sit. Yeah, let me tell you guys right now, you guys have not dealt with some of the stuff that I dealt with today. I had to just swallow my tongue for a few minutes and bite my tongue and just sort of run with it and but sometimes life gives you speed bumps and you deal with it and you move on and you make the best of it. So keep that in mind as whatever you guys go through. Be thankful for what you have. I've heard a lot this over Christmas break, just some of the stuff I've been listening to and reading about being uncomfortable, and being uncomfortable makes us better people. So with that being said, let's get a little uncomfortable with our next step in math. We are moving into operations and what's called rational functions. And we'll walk you guys through it. We're going to start off with some stuff that you guys know. And I want you guys to think of it like this right here. This is just handheld. I'm getting the little tripod one that you guys are going to be able to see and be like, oh man, that's so cool. I hope that's what you guys say. I don't know if that's going to be the first word out of your mouth. Some of you guys are going to be like, God, this guy. Okay, anyway. So we'll do our best here to make this work. Okay, think about it like this, right? McDonald's sells French fries. And there's a function for how many French fries they sell. Like they sell per person that comes in, they sell like, 0.4 French fries or large French fries that come in. Well, and then they have hamburgers or cheeseburgers, maybe both. Okay, and for every one person that walks in, they might sell, 0.8, and cheeseburgers they might sell 0.9, something like that. Maybe they're really good at selling cheeseburgers. Who knows? Well, what about combinations? Or what about like, hey, someone got a hamburger but not this? And we're starting to combine these, and we're putting this in a business form. Okay, so that's sort of the why of what we're doing right now. And what we're going to do is we're going to start throwing out some equations and rules with this. And so we'll just go along with it for a few minutes, and I want you guys to sort of get the concept. Okay, so far we all understand that f of x, well, that's also y, but this is the rule of the function. So remember, this is function f, okay? And then we have g of x, okay? So this is function g, this is function f. And that's just the name of them. And if we were graphing both those out, like they could look like two different things, like, hey, this is function f, and, there's function g, okay? That's a g. Stop making fun of my g's. I know you guys love doing that. Okay. Okay, so here we go. If I have, what we're trying to find out though, is what happens when we add function f and function g. Okay, well we can look at that two different ways and just sort of go with it here. This is function f of x plus g of x. Okay, so let's sort of get that concept right there. Okay, so all we're doing is adding in the two functions. Okay, well, let's put some numbers with this now. And we'll jump over here to the next page, and hopefully I can get this and do this at the same time. All right, so let's put some numbers to this now. So if I said f of x, and I'm going to get a dry erase board. Look, you guys don't understand what I dealt with today, so just go with it. All right, so f of x equals 2x plus 1. All right, and our rule for g of x equals x minus 3, okay? So we have g of x equals x minus 3. We have f of x equals 2x plus 1. All right, well, let's do exactly what we just said over here. And we're going to say f plus g of x equals. Okay, well, how did we break this up? We said this is f of x. This is f of x plus g of x equals. All right, well, what's f of x? This is 2x plus 1 plus, and we're just using substitution property here, plus x minus 3. Okay? All right, and we're still just combining like terms. All right, and so remember, we're adding straight across right here, so really the parentheses don't even exist. So I mean, if we wanted to, we could rewrite this. I wouldn't, but you know, it's up to you. X minus 3, because we're adding right there. If it was subtraction, we all know what to do, and multiplication and so forth. Anyway, all right, so we have 2x plus 1x, that gives us 3x. And then 1 minus 3, that's minus 2. So our final answer here, our final answer of f plus g of x equals 3x minus 2. Okay? If there was a number in place of that x right there, okay, so we'll hit one of these here in just a second. I don't want to leave you guys hanging like that. Let's see here, what else? Okay, so this time, now we have f, that's a horrible f, sorry, f of x minus g of x, okay? And again, we would just see a minus sign right there instead of a plus sign. Okay, so same deal, 2x plus 1 minus x minus 3. Okay, well, remember what we did last time. Flip all those signs. And so we're going to go minus x and plus 3. So 2x minus x, we have 1x. And we have 1 plus 3, we have 4. So there's our answer for that. I got to turn the page. This whole thing's getting annoying. Okay, let's put up a couple new rules here. Where was I? All right, cool. So let's say that f of x in this case is going to be x squared plus 7x plus 12. Okay, and g of x equals x squared minus 9. Okay. So we still got to do multiplication and division. So this time we have f times g of x. F times g of x. Okay, well, let's break that up. We have f of x times g of x. Or it could be written like this. It's all the same thing. Okay, so all the same thing. But again, we're just going to go substitute. So I got x squared plus 7x plus 12 times x squared minus 9. So I have my f of x right here, and I have my g of x right here. All right, so I go ahead and multiply this through, and we're going to have x squared, and this is, I'm sorry, not x squared, my bad. X to the fourth minus 9x squared. So that takes care of the x squared. Then we have 7x. This is going to be plus 7x to the third. So this is where we ended, not really ended, but this is where we were like December 1st. 7x times x squared gives us 7x to the third. And 7x minus 9 gives us minus 63x. And we have 12 times x squared plus 12x squared and minus, let's see, 108. All right. So let's go ahead and simplify this, break it down. I got x to the fourth plus 7x cubed plus 3x squared. So 7x cubed, x to the fourth, 3x, minus 63x minus 108. Okay? All right, and there's our final answer when we multiply those two. All right, and then finally, we got to divide. So we're going to have f of x divided by g of x. Okay, and just like the other ones, this could be written like this. F divided by g, x, something like that, or of x, okay. Same thing here. So again, let's plug in. Let's use these same numbers here. And it's whatever the rule is that's given to us, that's what we have to use. So we have x squared plus 7x plus 12 over x squared minus 9. Now, oh, I don't care. Yeah, that's fine. Hey, yeah, I appreciate it though. Thanks. I mean, I need to use it myself in a minute. Hey, you're good. You're good. Look, it's a public place. We all got to get to know. Maybe they wanted help on math, and that's why they came over here. You guys don't know. All right, so here we go. Now, when you guys do this, we need to understand that the denominator goes to all three. And I know some of you guys are going to go, hey, well, I have x squared and x squared, and just cancel those out. You cannot do that. Don't do that. I know some of you guys want to. Don't do that. This denominator goes to all three terms. So we have to treat this just like it's two separate things right now. Okay? So when I look at the top, can you simplify the top or can you factor the top? Like, what can we do? And that's sometimes all we have to do is like, hey, what can I do right now? So when we do this here, we got to look at this, and I got to go, oh, well, wait a minute. I can what are the factors of 12 that give us positive 7? Okay, well, I got 3 and 4. That gives me positive 7. All right, so we got x plus 3 and x plus 4 over, that's a horrible fraction line, okay, over, and I have the difference of two squares right here. So remember that one? That's our, like, x plus 3, x minus 3, okay? Now I have terms multiplying. This we like, because I'm multiplying these things. This isn't x and x. This is x plus 3. That's the whole term. And when I have the same thing on top and the same thing on bottom, you guys know this, that's 1. So my final answer here when we do this division is going to be x plus 4 divided by x minus 3. There's our answer. Okay. Let's take a look at it. So there's the basis right there of what we're sort of looking at. And let's finish this up with plugging in some values for it. Okay, and that's sort of where I want to end it at, and make sure that everyone gets the idea. Whatever's in place of x when we do this, you have to substitute that in. And it doesn't matter when you do it. You could do it at the very beginning. You could do it at the end. You're going to get the same answer. Okay? So let's take one more here, and just one from your assignment tonight. And we'll do it with division again. Okay, we'll do it with division. Make sure everyone's no, okay. I'm going to make up a number, but yeah, this concept is from your assignment though. Okay, here we go. So, I got to use this page. This side's working. The other side not working too well. All right, and trust me, we'll get all this squared away. Give me like a week. Trust me, today was a headache. Anyway, all right, here we go. So I got f of x equals negative 3a. And if you want to look along, I'm looking at 15, and we'll just make it the correct letter too. So this is g of x. This is g of x, equals negative 3a squared minus a. Okay, and I'm just going to rewrite this. I hate that up there. G of x equals negative 3a squared minus a. Okay? And I have h of x, or h of a. Sorry, it's been a long day, guys. I will get this straight. Nothing's changed. Okay. So there we go. Okay. Boom. We have h of a equals negative 2a minus 4. All right. So there's our rules right there. Now, what are we doing with those things? All right. So this is what we're doing. And the book is just using a, and I'll do it like that, but I'll also do it with a number here in a second. Or not the book, but the assignment. G over h of a. Okay. Awesome. So we just talked about this. Is that all we're doing is we're going to substitute in the function up here, that this is the same thing of g of a over h of a. Okay? Now, I also want to pause right here real fast, because I understand some of you guys too. Like, I want you guys to recognize there are lines on the page. Okay? Notice I am not and through this whole thing, okay, I'm using the lines. And this is completely random. This is not planned. Even if I go back to whatever I was working on there. I'm using the lines. It's not just complete chicken scratch all over the place, okay? Use what's given to you. Like, let's make sense of it, okay? All right, so back to this. All right, so I have g of a equals negative 3a squared minus a, and I have h of a equals negative 2a minus 4. All right, and I have g of a on top. So again, let's substitute this in. Equals negative 3a squared minus a over, and let's substitute h, negative 2a minus 4. Okay, so we get to this point, and remember the denominator, the whole denominator, goes to both terms, separately. So, and again, I know some of you guys are going to look at this and be like, there's an a there, there's an a there, I could just cross those off. No, don't do that. Don't, stop it right now. But what do we notice? I notice that everything's negative. I might be able to do something with that, okay? I also notice that just in the top that both terms have an A. Both terms have an A. So when I look at this here, I can actually pull out one of those A's, okay? I can pull out one of those A's. I can also pull out a negative 1. So we're going to pull out that negative, or negative 1, times A. And then I have 3a plus 1. Okay? If I was to multiply these both back in, I should end up back up here. That's how we're checking our work. So if I multiply this negative 1 times a, I end up with negative a. Negative a times 3a is negative 3a squared. Negative a times negative 1, negative a. So notice that we just end up going back up one level. All right, let's do the same thing on the bottom. So down here, I have a negative 1. I know I can pull that out, or you could just go straight negative 2 if you wanted. But I also have 2 in common. So I end up with a plus 2. Okay, now let's break this down and see what we have left over. I have a negative 1 on top and a negative 1 on bottom. Those are gone. Okay? You also could have noticed that, hey, they're all negative and just made them all positive. Like that would have worked too. Okay? But what else can I eliminate? I can't really do anything. So really, I'm done. This is a times 3a plus 1 and 2 times a plus 2. Most likely you're going to have to put it back in, so leave it alone. This is 3a squared plus a over 2a plus 2. If I wrote down the right numbers. I think I did. Yeah, I think that's right. Okay. Now, I said a minute ago, like, if there was a value in there for a or whatever it was, like maybe the value's 2. At the very beginning, you can go plug in 2. You could have plugged in 2 right here, gone through your steps, and gone about it. You can also do all this first because sometimes they're going to require both. And then you can plug in 2 at the end. So, and the way you would see that right here would be like this. It would look like G divided by H times 2. And then you would just do all the same steps, except instead of A, it'd be 2. So, all right, I'm going to load up this assignment. If you guys have questions, message me. Today was a busy day. I don't know what is in store for me tomorrow, but have a good day. Go enjoy yourselves, and make sure you guys get the assignment done. I'm going to load up another one tomorrow sometime. All right, awesome. Keep up the good work, guys. Bye.